block diagram. Okay. Now what is a block diagram? N number of times we use the word what is block diagram, block diagram, block diagram. So block diagram is nothing but, now you already know the basics of the control system, open loop control system, closed loop control system, what are the components present, right? So the block diagram is nothing but a short and picture representation of a system or a control system between input to output. But now see here, when I am asking a block diagram of open loop control system, you never take controller, processor, all these things you are not taking. You just say that, sir, this is input R of S. Now this is forward path gain G of S. Now this is output C of S. That's it. This is a short form picture representation between input to output. Now the short and picture representation of a system or a control system between input to output is nothing but a block diagram. This is the block diagram of open loop control system. Similarly, when I am asking what is the block diagram of closed loop control system, then no controller, no processor, nothing. This is the forward path gain. This is the feedback path gain. This is output. This is input. Now what is the transfer function? C of S by R of S, which is equal to G of S by 1 plus G of S into H of S. Now this is the closed loop control system transfer function, and this is the closed loop control system block diagram. Now this is the open loop control system block diagram. From that you can easily find the transfer function C of S by R of S, which is equal to G of S. This is the forward path gain. Now this is the feedback path gain. This is the closed loop control system transfer function. And this is the short form and picture representation between input to output, right? Now this is also the block diagram. This is the forward path gain G of S, and this is the feedback path gain H of S. This is C of S, this is R of S. Now this is the closed loop control system transfer function. This is the closed loop control system transfer function C of S by R of S, which is equal to G of S by 1 minus G of S into H of S. This is the closed loop control system transfer function. Now this is positive feedback. Now this is positive feedback. This is the negative feedback. Now before with that, what is a block diagram? The block diagram is nothing but short form and picture representation between input to output, So, but there is no need of always the block diagram is only in a short form. Am I right or not? So, depends upon the application, depends upon the components involved in that particular processor. Now, definitely the number of blocks may be more. Okay, but if the block diagram is like this, forward path gain, feedback path gain, negative feedback, positive feedback, you can get the answer very easily. So what we are doing is, if more number of blocks are available in your block diagram, or because of different applications or different process involved in that particular system, so sometimes the blocks may be more, sometimes the blocks may be complicated. So we use some rules and regulations such that now by using that rules and regulations, you simplify the blocks, you minimize the blocks. Whenever the minimum number of blocks are like this, you can easily find the transfer function. Okay, so that rules and regulations in the block diagram is called as block diagram reduction rules. Okay, that block diagram, that rules and regulations are used to reduce the more number of blocks to less number of blocks is called as a block diagram reduction rules. Okay. So now the students, I am asking on one question, which means that the block diagram rules and regulations are for what purpose? The block diagram reduction techniques and rules and regulations are used only for your simplification purpose, your flexibility. So minimize the blocks. Okay, don't disturb the input output relations by using your rules and regulations. If you disturb the input and output relations, then what happens? The input output relation is changed. A trans function is changed. A trans function is nothing but a mathematical equivalent model of a control system. The complete analysis which we can define from the trans function. Don't disturb the input and output relation. Only use the rules and regulations for easy process, for easy simplifications. Okay. So this is the block diagram definition and a shortest forms. Okay. Now we will see the rules and regulations, and after that we will solve the problems. Okay. Note on this. Now, this is rule 1. Blocks are connected in series. When blocks are connected in series, more number of blocks are connected in series. So how to minimize that? Let us take for example like this. Sometimes in your block diagram the situation may be like this. Now, like this, the blocks are connected in series. When the blocks are connected in series, so you can minimize the blocks like this. When blocks are connected in series, okay. When blocks are connected in series, then what is the overall block gain? When blocks are connected in series, gains are in cascade, then the overall block gain is nothing but multiplication. G1, G2, G3. So when blocks are connected in series, then the overall block gain is nothing but multiplication. Now this is A and this is A into Z1, G2, Z3. When blocks are connected in series, then the overall block gain is nothing but multiplication. Now this is A into G1, G2, G3, which is nothing but A into G1, G2, G3. Okay. So like that, your more number of blocks should be reduced and minimized. Okay. So if any situation in your block diagram, you can utilize this one, not a problem. Okay, no doubt. Now we'll take rule 2. When blocks are connected in parallel. When blocks are connected in parallel, maybe the situation like this. Now see here. Now this is all blocks are connected in parallel. Now this is the blocks which are connected in parallel. When blocks are connected in parallel, when blocks are connected in series, then the overall block gain is nothing but multiplication. When blocks are connected in parallel, then the overall block gain is nothing but summation. So can I write like this? G1 plus G2 plus G3, and your input output relation will not disturb. This is A. This is A into G1 plus G2 plus G3. Okay, no doubt. Now, shift the branch point, ahead of the block. Now if the situation is like this, now what is the purpose of all these rules and regulations? You understand or not? These rules and regulations are useful to you to simplify the blocks, okay, to minimize the blocks. Now see here, now this point is called as a branch point. Now this is the branch point or takeoff point. So no, now in our block diagram, now this branch point may be here, you can get a more advantage, okay. In such a situation is demanding, you can do that. So you may shift this branch point ahead of the block. You can shift that branch point to here, not a problem, not an issue. If you have a flexibility of minimizing the block from this side, you can do that, okay. So what are the changes it may take place while you shift the branch point, okay. So what happen? This is G, forward path gain. Now this is A. Now this is AG. But if this branch point is here, but this path value is AG, right? But your original path value is A, therefore, now this path will introduce a block of gain 1 by G. So now this is A. So now your input output relation will be changed. Now shifting the branch point ahead of the block, then this path will introduce a gain of reciprocal, okay. Not Okay. Now shift the branch point before the block. Shift the branch point before the block. Now the situation may be like this. Now this is the branch point, right? Now what he wants? He wants that this shift this branch point before the block. So we want to shift this branch point before the block. So if you want to shift like this, you can get a more advantage, you can do it. Okay. So what are the changes taking place while you are shifting this branch point before the block? But now your path value is here. Now this branch point is before the block. So this is A, this is A. But your original path is having a value of AG. Therefore, now this path will introduce a block of gain G. So this is AG. So this is the branch point. Now shift this branch point before the block. So if you shift this branch point before the block, these are the changes taking place. Okay. Now shift the summing point. Now you can shift the summing point also. Shift the summing point ahead of the block. This is the summing point first because he is asking to shift the summing point, right? Now this is the summing point. Now you just shift this summing point. Shift this summing point before. Now this is a summing point. What he is asking? Shift this summing point ahead of the block. So if you want to shift this summing point, you can get more advantage. Therefore you can shift that. Okay. So now if you shift that, now you want summing point here. So this path will introduce a block of gain G. Now this path will also introduce a block of gain G, but now your summing point is ahead of the block. Now first is block, next one is summing point. Shift the summing point ahead of the block. Now this is the summing point. Now you shift the summing point ahead of the block. Okay. Now this is the summing point. Now summing point is shifted ahead of the block. These are the changes taking place in the block diagram. Okay. Now we'll see. Shift the summing point before the block. Shift the summing point before the block. Shift the summing point before the block. Now this is the summing point, but now what his intention? His intention is to shift the summing point before the block. Okay, now the summing point should be shifted here. Then what are the changes taking place? Now first one is summing point now, because now this path will lose the gain and this path will add the gain. Now first one is summing point, because now the summing point is before the block. Yes. Now you want to shift the summing point before the block. Now these are the changes taking place. This block will be loosed and this part will add a gain of reciprocal, and your summing point is shifted before the block. Okay. So use these rules and regulations to simplify the block such that you can easily find the transfer function. And next one is, we can split the summing point also. Split the summing point. So sometimes the summing point is like this. So you can split the single summing point into two summing points also. Now this is a summing point. Now you can split this summing point into two summing points. Now this single summing point you can split into one is positive feedback, another one is negative feedback, or whatever it may be. Okay, you can split that single summing point into two summing points also. Okay. Okay. So use these block diagram reduction rules for minimizing the blocks in the given problem, or for easy simplifications, for easy calculations purpose. Okay. Now we'll solve the problem. Now this is one block diagram. See, more number of blocks involved here. So he is asking to find the transfer function. Okay. Now see here, he is asking to find the transfer function. Now first, now see here. Now first I want to simplify this parallel operation. Now see here, this is a parallel path. Just now we just see that is the advantage of this rules and regulation. Now when blocks are connected in parallel, then the overall block gain is nothing but a summation or not? Yes. Therefore, can I replace that? So clearly note down this first this diagram. Then I can erase this. I can write directly. Okay. So now see here. Then I want to apply the first step. When blocks are connected in parallel. So when blocks are connected in parallel, which means that then the overall block gain is nothing but addition. So G2 plus G4 plus 1. G2 plus G4, G2 plus G4 plus 1. When blocks are connected in parallel, now this is the overall block gain. Okay, G2 plus G4 plus 1, because all are connected in parallel. Next one is, now see here, this is the block, this is the forward path gain, this is forward path gain, and this is the feedback path gain. Forward path gain and a feedback path gain, and this is a negative feedback. Therefore, now this is the negative feedback, this is forward path gain and feedback path gain. This we can remove and we can write it as G2 by 1 plus G2 into H2, right? Now this is G2 by 1 plus G2 into H2. So where I am replacing previously what is there, now how you can get this, you can easily observe. Okay, now see here, now this is one block, this is another block, this is another block. Now all the three blocks connected in first rule, all the three blocks are connected in series. Now all the three blocks are connected in series, then what is the overall block gain? The overall block gain is nothing but multiplication. So can I write like this? G1 into G2 by 1 plus G2 H2 into G2 plus, that is not G2 I think, so this is G3, G3 plus G4 plus 1. Now see here, this is the overall blocks are connected in series. Therefore, this is the overall block gain. The overall block gain is nothing but multiplication, because all are connected in series. So what is there? In black pen where I am writing is the replacement. Blue is actual, original, what is given. Okay, like that you can identify. Now the transfer function, easy now. C of S by R of S, which is equal to, now this is the forward path gain, right? So G by H, G by negative feedback, 1 plus G into H, simple answer, right? So now see here, so first you write as it is, numerator as it is, G1 G2 into G3 plus G4 plus 1, now divided by, now this is the negative feedback. Okay, if it is negative feedback, 1 plus, if it is a positive feedback, 1 minus. This is shortcut method I made. 1 plus and whatever here denominator that you can write 1 plus G2 H2. Listen, this is one shortcut method I am giving. Clearly observed here. Forward path G by negative feedback means 1 plus, positive feedback means 1 minus, then numerator into denominator. That's it. So 1 plus, and this one into what is numerator? G1, G2, G3 plus G4 plus 1 into this feedback path. This is a shortcut method directly. Okay. Even if you simplify also you can get the same answer. This one, sir. This is negative feedback 1 plus, first you write what is the denominator here, G2 H2 plus then numerator, all numerator, G1 G2 G3 plus G4 plus 1 into H1. This is the value directly. Now we'll solve another one. Find transfer function by considering the block diagram. Now see here. Now this is the block diagram which is given to you. Now first he is asking to find the transfer function. Now what should you do? You just tell me first. Now first you just see the any positive feedback or negative feedback terms are there. Now see here, this is forward path gain, this is the feedback path gain. Now this summing point, all these things are removed or not first immediately. Okay, this summing point, all these things are removed if you do like that. So now see here, now this operation first we want to remove this, okay, and this negative feedback also. So if you remove this, then what happens? This is G1 H1, right? G1 by negative feedback 1 plus G1 H1. But there is a forward path here is also, but there is a summing point also, because this is the summing point with positive here. Just summing point, this one. Now this one, now see here, now this negative feedback first we are removed here, and one more thing also you can see here. Now these two are connected in series, right? These two are connected in series, and this is one feedback path, but now this is positive feedback, right? So now if you see here, now this one, first we will see G1 G2, now which is nothing but here G1, both are connected in series, G1 G2 by 1 plus G1 H1. So both are connected in series, then I just do the parallel series connection cascading. Now see here clearly. Now this is the forward path, this is the forward path, and this is the feedback path, but which feedback? Positive feedback. Now I am giving one simple solution already, that is one shortcut method here. Instead of doing this simplification, all these things, I just do one thing, you remember. Numerator, first you write numerator as it is. Denominator, this is positive, therefore 1 minus. If it is negative feedback, 1 plus. So 1 minus, as it is you write, 1 minus G1 H1, 1 minus G1 H1, next plus this numerator into last, that one. Okay, clear or not? Now see here. Now I just remove this one, this total. Carefully write, okay. Numerator is as it is, numerator you write first, which means that G1 G2. Listen carefully, denominator I am writing here, forward path no problem, denominator. So this is the positive feedback, therefore this is a positive feedback, okay. So you denominator, what is the denominator actually? 1 plus G1 H1, okay. So actually here is like this, G1 G2 by 1 plus G1 H1. This is the forward path is already available, but now there is a feedback path like this, right? What is the feedback path? Feedback path is H2. Actually this is the situation, right? See carefully, you just observe here. This is the path actually, okay. Now students, you just carefully here. This is the forward path and this is the feedback path, but this is which feedback? Positive feedback. So for that cases I am writing directly. First you write as it is, G1 forward path as it is, G1 G2 by 1 plus G1 H1, okay. This is clearly. Then after that, then this loop gain is nothing but this is the positive feedback. This is the positive feedback, therefore you write minus. If this is a negative feedback, you write here plus. Understand or not? Okay. This is the positive feedback, therefore this is minus. Now, just multiply forward path G1 G2, G1 Z2, G1 Z2 forward path. Lastly, multiplied with feedback path G1 G2 into H2, that's it. Previously also I am explaining same. Suppose if this is the same situation, again I am explaining. This is the same situation, but this is the negative feedback. How you can write? As it is first, G1 Z2 by 1 plus G1 H1 as it is. Up to this particular point, no doubt. But now this is the negative feedback. Therefore, here plus forward path gain component, numerator component. What is numerator component? G1, G2, lastly multiplied with feedback path gain. What is the feedback path gain? H2. Like that is the only difference. Okay, if it is a negative feedback. Clear or not? Okay. Next, now these two are connected in series. Okay, so these two are connected in series, therefore you cancel these two. So finally this fellow is coming here. Which fellow? G3. So G1 G2 into G3. Now you tell me what happened. Now you tell me. Now this is, okay, now you just carefully observe here. Now you try to this. This is one forward path. Clearly, students, use it. This is one forward path, and this is the feedback path. But which feedback here? This is the forward path, and this is the feedback path. But which feedback? The feedback here is negative. How I am writing? What is the shortcut method I am applying here? What is the shortcut method? See here. First numerator is as it is. G1, G2, G3. Denominator is also as it is. Denominator is as it is. 1 plus G1 H1 minus G1 G2 H2. Up to this particular point now, forward path gain as it is everywhere. G1 G2 G3 by 1 plus as it is. Now you just have, now you add only one term. What is one term? Now there is a negative feedback. Negative feedback means what I am saying. Positive feedback means here minus, but negative feedback means plus. Sorry, negative feedback means here it is plus. Now forward path gain G1 G2 G3 multiplied with feedback path gain. What is the feedback path gain? H3. That's it. This is the shortcut method. Understand, student? This is one shortcut method. Otherwise, this is G, this is H, G by 1 plus G into H. Simplification, cross multiplication, LCM, cancel, all these things. This is the answer directly, shortcut method. Right. Now this is closed. Finally, now this is R of S. Now this feedback is already given. But now there is a feedback here. Now see here. Now first you simplify this. This is the cascaded forward path gain. Therefore this G4 is removed and come to here. This is G4. Now this is the forward path, and again this is the feedback path. Listen carefully. This is the feedback path. But now this is which feedback? Positive feedback. So what is the answer I am saying? What is the answer? Now you tell me what is the answer. You tell me the answer directly. Now the transfer function C of S by R of S, which is equal to, first numerator as it is you write, G1, G2, G3, G4. Denominator as it is 1 plus G1, H1 minus G1, G2, H2 plus G1, G2, G3, H3. Now last term is only change. What is the last term? This is the positive feedback. Positive feedback means here minus. If it is negative feedback, plus. Then numerator as it is. What is the numerator? G1, G2, G3, G4 multiplied with feedback. What is the feedback? Feedback path gain is 1. Just multiplied with feedback path gain is 1. This is the transfer function. Clear or not? No.